Here's a chart that has most of the more popular hypothesis tests. We start off with a normality test. What we're trying to show there is our data compared to normal data, is there any difference there? The Anderson-Darling normality test is the most popular. The next thing is variance. Do we have equal variance between groups? We would select our test, either the F-test, Bartlett's test, or Levene's test, based on the number of groups that we have there. If we're trying to compare means, and we've already shown that we have normal data using the Anderson-Darling test, then if we have two independent means, we're going to use the two-sample test. If we have two dependent means, we're going to use the paired t-test. If we have more than two means, we're going to use analysis of variance or ANOVA. If we're trying to show inequality of means, but we know that we do not have normal data, then we'd either use the Mann-Whitney, Kruskal-Wallis, Moods median test. If we have attribute data and we're trying to compare proportions, we would use either a two-sample p-test or a chi-squared test. In this session of hypothesis testing, we covered what hypothesis testing is and why we would use it, the p-values and how we use that in comparison to our alpha values, our alpha and beta risks and what we're assuming with those numbers, and then the different types of hypothesis tests based on the type of data that we have, the type of statistical parameter that we're trying to compare, and then how many samples or the specific aspects of our samples.